Hello, this video is going to discuss hypothesis testing for variance and standard deviation. And when we're discussing variance and standard deviation, we generally use the chi-square distribution. So we need to find, those are going to be our test statistic. So we're going to specify our level of significance as we did with other hypothesis tests. Find our degrees of freedom, just like we do with the t-test. And the critical values for the chi-square distribution are found on the chi-square table. And to find the critical values for a right-tailed test, the value corresponds to alpha for a left-tailed test, 1 minus alpha, and for a two-tailed test, 1 minus 1/2 alpha. So if we want to find the critical value for a left-tailed test with n equal to 19 and a 0.05 alpha level, we know that degrees of freedom is going to be n minus 1, so that's 18. And the area to the right of the critical value is going to be 1 minus alpha. So we have 1 minus 0.05. And that gives us 0.95. If we look up that value with 18 degrees of freedom, we will find 9.39 for our chi-square value. And find the critical value for a two-tailed test. Here's another example. If we have n equal to 26, we know we have 25 degrees of freedom. And at the alpha 0.01 level, this is a two-tailed test, so we use this formula. We get a value of 0.995. And from the critical values, we need a left value and a right value. And so that's something else that we need to pay attention to with the chi-square distribution. So the chi-square test is our statistical test for variance and standard deviation, and can be used when the population is normal. So it's another parametric statistic. And the test statistic is s squared. That's our variance. And the way we find chi-square is through this formula. Sample minus 1, which is also the degrees of freedom, times the variance of the sample over the variance of the population. Follows a chi-square distribution with degrees of freedom n minus 1. And these are the steps for conducting the chi-square test. And the first is, of course, to state our null and our alternative hypotheses, identify our alpha level of significance, determine our degrees of freedom at n minus 1, and then find any critical values using our chi-square table. The next step is to determine our rejection regions, again based on whether we're looking at a right, left, or two-tailed test. We find the standardized test statistic using our formula. Then we make a decision to reject or fail to reject our null hypothesis, HO, and interpret the decision in the context of the original claim. And here's an example. A college professor claims that the standard deviation for students taking a statistics test is less than 30. 10 tests are randomly selected with a standard deviation of 28.8. And we want to test the claim at the 0.01 level. And so we have our null that the standard deviation is greater than or equal to 30, and our alternative, which is the claim that it is less than 30. So this is a left-tailed test with degrees of freedom of 9, since we have 10 people, at a 0.01 level. So our next step then is to determine our cutoff value for chi-square, which at 9 degrees of freedom at the 0.01 level is 2.088. And then we find our test statistic using our formula. We plug in these values, and we find 8.29. And 8.29 is far larger than 2, somewhere over here. Therefore, it is not in our rejection region, and we fail to reject the null hypothesis. And that means that there is not enough evidence to support the professor's claim. Here's another example. A local balloon company claims that variance for the time its helium balloons will stay afloat is 5 hours. A disgruntled customer wants to test that claim and randomly selects 23 customers, finds that the variance of the sample is 4.5 seconds. So at a 0.05 alpha level, does she have enough evidence to reject the claim? That's what we're going to test. So the null is the claim that variance is equal to 5, and the alternative is that it does not equal 5. So this is a two-tailed test with 22 degrees of freedom, since we have 23 people in the sample, at a 0.05 level. So we'll use the appropriate formula for finding our cutoff values. And based on our chi-square distribution table, And using these formulas for the right and the left critical values, we find 0.025. And so we have, at the 0.025 rejection region, we have 10.982 and 36.781 as the cutoff values. And the next step is to determine our test statistic using our equation here for chi-square. And if we plug in our values, we come to 19.8, and that does fall in the non-rejection area because it's between the two cutoff values. So at alpha 0.05, there's not enough evidence to reject the claim that the variance of float time is 5 hours.